Hello and a warm welcome back. Today on the bench is the bloody valve tester again, but we're getting towards the end now. This is about the penultimate episode, I promise you. Right, what we got to address. Chap in the last video, somebody, I presume it was a chap, somebody in the last video said this is a very poor design, do not build this, there are better designs out there. I wouldn't go as far as saying it's a poor design, but there are probably better designs out there if you want to build a valve tester. This valve tester I'm building the way I want to, because I'm used to working in such a way, and I test certain valves that probably other people won't test. So it's my valve tester, so this isn't, don't think of this as here's a valve tester, build it exactly like I've built it and everything will be fine. It won't. This is just basically me building shit, you following along and hopefully picking up a few tips along the way, yada yada yada. So what have I done? Sorted out the patch board, although I still haven't put a bloody bolt in there, one of the things you forget as you go along. Rejigged all the what do you call it, patch cords, let's call them, so that the cathode one is obviously black and it's got two, basically one from the ground and then two there so I can test dual triodes. We've got two anode patches, patch leads, let's call them. The bias has got again split into two so that we can test dual triodes, and then our heater leads, patch leads, or like the, let's call it the black one, is just like a standard lead. The red one I'm able, through the cunning use of these sort of 4mm banana sockets, to put another one like that, so that put that in there, and if I want to test say like an ECC83 that's got heaters on pin 4, 5 and 9, I'll go to 4 and 5 and the other one goes to pin 9. Hope that makes sense. The other thing I've done is to put some on-off switches, because that was one of the things last time that was a bit stupid to not put on, and all I've done there is, instead of like switching the high voltage, I've just switched that to our ground bus. So the anode one, because it's quite high current, is a, where are we, double pole single throw. I don't know, it's a double pole, I don't know, you know what the fuck it is. Anyway, these two switches in there and they're paralleled because we've got higher current. Screen grid one is just like a, you know, single, where are we, double pole single throw switch. And then the heater one wanted to be a bit more, the heater one wanted to be a bit more chunky because we've got a lot more current. Right, I've also modded the bias supply to make it higher or lower depending on which way you look at it. When you're testing things like 6080s and other series pass valves like the 12E14s that I've showed you before, they are totally different to your normal pentode tetrode, in that they have quite low gain and they have a very high current. They're capable of very high current, but they also have a very low anode resistance. So testing them is difficult. With this supply only being able to go down to about 175 volts, if you look at the 6080 dynamic characteristics graph, that would mean that each one of these triodes in the 6080 is capable of 13 watts. If we're testing them at 175 volts at, say, where we'll be before, about 50 volts, that would exceed the maximum power dissipation of the valve. So rather than trying to jiggle the anode supply to make it go lower, all I did was just bunged in a transformer with loads of different taps off it, so that our bias voltage can go down lower or higher, whichever way you think about it. I did think about using this transformer, which is one of the transformers that I've picked up over the years and no idea where it came from. So basically what we've got a primary, which is, where are we, 0, 5, 10, 115, 130, 140, 230, 250, 290 volts there, and then we've got 12 volts there. So a lot of valve testers use this sort of thing, where they got one transformer here feeding another transformer that feeds the heaters, and then we get all these various voltages out for the secondaries. You know, we switch the secondary and the primary. However, that involves lots of switching, and where the feck am I going to put it? It's getting tight in room, you know, for room in there. So I discounted that idea. Right, what a lot of valve testers do, the Steve Bencher's rat tester, and I think the Sussex that's on the UK VRR forum does, to get past this problem, what they do, they have like a Zener string. So say each one of these Zeners is 20 volts, 20 volts, 40 volts, 60 volts. And then before the regulator proper, as it were, they've got like another series pass transistor or something like that. And if you switch that like that, then that alters the voltage going to your series pass element of your regulator. Again, I didn't want to do that. Don't want to include loads of switches, and I don't want to be arsed with like making more circuit boards than I have to. Discounted that, so I went with the increasing the bias. Alright, before I go fitting the Felpham transconductance GM measuring thingy doodah PCB and gas tests and all that sort of thing, I want to make sure that all the power supplies we've got in there are okay, and I'll give them a bit of a soak test. Oh, one thing, I built a different screen supply, and I also built a split rail supply for the Felpham PCB, which is minus 15, oh sorry, yeah, minus 15 plus 15 regulated power supply. I had a bit of a issue with this one, in that as it was regulating at too low a current, i.e. current limiting at too low a current than I wanted it, so I made some changes. It took me a little while to get there. I'm no expert, but I'm just like a tinkerer, so there's a lot more knowledgeable people out there that watch these videos. So the first thing I did, I got rid of this 100R and 220N capacitor. Wasn't needed. That was something to do with the transconductance GM test of the Steve Bench thing. This is what Susie sent us. Day stay. What I did do though, we had a 10 ohm resistor here, and what I found was it was just basically with a resistive load, it would go into regulation, current limiting should I say, too quickly for what I wanted. Yes, a screen grid is only going to be pulling what, 5, 10, 15, 20 milliamps, but I'm going to be hopefully testing like big fuck off bells with this, so we need something a bit more. We need something capable of providing more current. So I put another 10 ohm resistor in parallel with that resistor there, and then what I did as well, I reduced the value of this 1 meg resistor here to 470k, because what I've found, and it took me a while to suss this out, was when you get an overcurrent situation, you get a voltage drop across here which switches this transistor on, which then obviously pulls current through these resistors here, and that gives you the voltage drop, which drops the voltage to your MOSFET and thus puts it into current limiting mode. I just fettled it how I wanted it and it works. Right, let's test some valves. I'm going to test the 6080, and yesterday I was having a little bit of a knockabout. This is just by way of soak testing all the various power supplies. Now then, this, as far as I know, is a new old stock 6080. I can't find the valve. It came in a box, so it's some 6080s I recently got. It looks new. Let's bang that in, and because I've got all the voltages dialed in, we should just be able to crack on with it. Valve tester on. Jesus, this damn thing. Let's try putting something underneath there for you. That's better, isn't it? Right, minus 80 volts. Let's bung our heater on. I know it's not quite bang on, but there we go. Right, now we'll whack the anode voltage on. 175. Right, I'll point you at the ammeters. Okay, so we're getting a bit better results here, but it's still not fantastic, is it? It could be that this is a new old stock valve and it just needs a bit of running in or something. It might be a bit gassy or something. Yeah. So when I was testing this yesterday, I thought there was something up with my anode power supply, and so I tested it, and basically I could get 200 milliamps out of the anode power supply easily. And this is a bit weird because I'm using a 6080 regulated power supply to test the 6080. So as you can see, that one doesn't measure that much. Right, let's kill that, turn that off. Right, next we're testing a GEC. Again, I think this is new old stock 6080. There is a point to all this. Basically, this testing is telling me whether the power supply and everything that I built is working as per. Right, over to a bias voltage, minus 80, heater voltage on. See, after a while with tested like this, you can get into a rhythm. Right, that's cushy. Going to our anode voltage. Bang, anode voltage on. Pop you over there. Now then, you watch those meters. See? Now we're getting something a bit more like, aren't we? The 70 milliamps that the spec sheet says. So that's saying that both triodes have got really good emission, and that one in that case is really pulling volts, current should I say. Now then, no, I know my anode supply is capable of 200 milliamps easily, even though it's an old pull, so we know that that one's a good one. Right, I'm going to kill that. So as you can see, the valve tester works as an emission tester, and all the power supplies we've tested so far are working as per. Next I'm going to test various 807s, and we are going to test an 807 that I know is a bit gassy and has blown up several MOSFETs beforehand. Right, watch this. When I switch this voltage switch, Let's try and keep my hands out of the way without getting electrocuted. Something not right there. I'm going to have a look at that. So this is what I was talking about when I was going on about, yakking on about MOSFET, source follower, variable power supplies dying when you get a transient or some other thing. Basically, I've found no protection method, be it like a reverse diode across the MOSFET, these diodes here, these two Zenas, gate resistors and all the rest of it. Nothing I've found can protect these very sensitive devices. So when the fuck up happened, which was entirely my fault, it blew the MOSFET, it blew one of the protection diodes, the two resistors that I had, the two sense resistors. Basically I had two 10 ohm sense resistors to give us 5 ohm sense resistor. One went open circuit and the other one went high. I've had these problems before. These are V-Shay 2 watt resistors, believe it or not. What is that, a CPF series? Dale, oh no, sorry, Dale, which is V-Shay basically, CPF, blah blah blah. I've had the bloody problem with these buggers before. Won't be using them again. So, well, they're probably really good resistors, but no good for this application. So that's what happened. And yeah, I've not found anything that can protect against it. It's just, it's a consequence. But the thing is, you can't use I suppose you could use valves for every power supply, but that'd be a bit mad. At this point, I've been at this fiddling about with this thing for a few weeks, and any enthusiasm and get up and go that I had was got up and gone basically. I'm just fed up with the damn thing for now. So I'm going to put it aside for a few weeks. I dare say you're fed up with seeing the damn thing, same as I am. Put it aside for a few weeks. Let's go and work on something different, and then hopefully in a week or two come back, have another look at it, and then me enthusiasm may have returned. Thank you very much for watching and sticking through this interminable series of videos. Take care of yourselves. Ta-da for now.